ladies and gentlemen, we have a special installment today on the Kurz Wind Podcast. Through lots of back and forth and a lot of mutual friends recommending I get in touch with this individual, we're finally able to find a spot to get him on the podcast. I'd like to introduce you all to Stephen Steen with Poseidon Systems. If you have anything to do with wind at all, with operations, maintenance, even if you're any end user, you've probably heard of this company. They have a fabulous reputation in the industry. Stephen, I really appreciate you coming on the show. And I just want to kick it off with just a brief overview of who you are, maybe a brief overview of Poseidon Systems, and then also what your role is at the company.
Yeah, thanks for having me. Good to finally find a time to get together. So I'm Stephen Steen. I'm the Vice President of Industrial Internet of Things for Poseidon, and kind of high level of Poseidon, we make condition monitoring systems, more specific as a solution to individual types of needs, such as wind turbines, which is what we're talking about today. But we also do things in other industries, such as mining and off-road vehicles and that sort of thing. So it's quite a wide range of things that we do in that space. But as you can tell by the name Poseidon, it's maybe not readily apparent, but the idea behind that is, God of ocean and that sort of thing. And we do a lot of our sensors and stuff are around the fluids within a system. So we thought it was a neat little correlation to have something unique with fluids and water, because that's the type of sensors that we're focused on in manufacture.
Really cool, Stephen. And this is a little bit of a curveball here, but how long has Poseidon been operating in the wind space specifically, if you have a number?
In the wind space, trials started around before they were Poseidon under a different name as part of another company that split off from, and around the 2008 or so timeframe. Let's say the current technology, the current system went into trials on wind turbines around 2014, 2016, and then really as an end product to sell to customers at large scale, final solution, only the past 3 to 4 years.
Very cool. And we're definitely going to dive into what you guys got cooking in the background at Poseidon and what you've actually been able to do thus far with different customers. But first, Stephen, I want to focus on you. You have a very extensive background. We talked offline before we got onto this podcast. You're an engineer for 15 plus years. Can you walk me through kind of your career path that ended up landing you this position as vice president at Poseidon Systems?
Yeah, so I've kind of been a little bit all over different industries and different technologies. So I actually started right out of high school on road construction and irrigation construction. So I drove dump trucks and a lot of other laying pipe and drainage and that sort of thing with the county. And while I was doing that, I was working my way through college. I got 2 engineering degrees while I was there, and jumped right into automotive engineering. So vehicle control systems and hybrid vehicles for the slip control and the braking. And while I was doing that, I worked on my MBA from Colorado State, so I kind of did both at the same time early on before I had kids. So we during that time I got married. We now have 4 kids. The oldest one actually today turned 16, so it's happy birthday, Hosanna. She ends up watching this, probably not, but if so. And then the youngest is all the way down to 1.5 years, so quite a wide range in ages there. But while I was at automotive, really I saw wind turbines around Ohio, a couple locations where I'd grown up and really wanted to get in the wind. So I joined Clipper. And I just kind of joined as a general electrical engineer doing random stuff. And if anybody knows the story of Clipper, there's a lot of stuff to fix. So I went straight out to the field in Iowa, went from doing electrical engineering on automotive to glassing blades and fixing patches and that sort of stuff on fiberglass. And after that, the condition monitoring system kind of fell in my lap. It was something nobody else wanted to do. And again, if you know the story of Clipper, a lot of stuff to monitor and a lot of ways to validate things. And that's actually how I initially got connected to Poseidon, was in that role. I went through and I tested all the vibration, the acoustic sensing technologies, wear, debris, and particle counters. And through that testing, the Poseidon technology kind of really just surfaced in that. And I actually ended up selecting their technology as basically the highest accuracy, earliest detection on gearbox failures at a much lower cost than a lot of the other technologies that were available. So that goes all the way back to the 2010 timeframe when they were very, very, very early in the market.
That's really interesting. Go ahead. Sorry, Stephen.
Yeah, and then just right after that, I kind of jumped around into a couple IoT and machine learning, which is a little bit more related to what my title is today. So how do you use different sort of technologies and engineering tools and big data to tease out, important or useful information from the data you have, whether it be the SCADA system or anything like that, before I came back and joined Poseidon.
That is so neat. So this is another curveball for you, Stephen, but you see a lot of these different machines out there, Siemens Gamesa, you've got the Vestas, I think V150s now, these monstrous turbines, GE 15s now all the way up to their 5X Cypress platform. How did Clipper compare just from like the electrical and mechanical components to these other turbines? So let's say a stock GE 15 turbine, non-ESS, because I believe Clipper doesn't have a gearbox, so there's something different about the Clipper technology versus the others. I'd actually love to hear selfishly how they differentiated and what challenges came about when working on those machines versus others.
Yeah, it was extremely unique design from top to bottom. There was an attempt to reduce the generator size, and so it was a split torque, shared torque gearbox. So it actually took the input shaft, and instead of going to a main bearing shaft into a planetary gearbox with one generator, actually split that out into 4 generators. So it was a 2.5 megawatt machine with 4 660 some odd kilowatt generators, which were easily replaceable. That tested very well on the ground. It happened to be that through trial and error, learning how to manufacture them and install them and build the system, there were just some kind of slight variances on timing of gear sets and everything else that caused a lot of that new innovative ideas that were had that may or may not have been good ideas, had too much to learn before applying it to the field. So they had basically installed 700 plus turbines before I had joined, trying to work on it and fix some of those problems. And because of all the uniqueness and not a lot of history behind it, wind turbines are a very, very tough place to put in new technologies. And it was just a little bit too much new technology at one time. Whether or not any of those individual ideas were great or not, irrelevant if it doesn't come together as a final product that's reliable.
That's really interesting. I appreciate that feedback too. I'm sure, and I've heard this from different people in the industry, that Clipper was extremely innovative at the time, and you're still seeing people trying to adopt similar technologies or take some ideas that Clipper was able to put together early on in the big boom of wind in the United States, and now try and parcel that out to different technologies and different types of turbines. So I'd be really interested to see how that kind of evolves over time and how the technologies change. You had said something striking to me, and I want to kind of hammer in on it. You had said that your role at Clipper was to identify the best company to be able to do condition monitoring, and you actually went with Poseidon Systems, and now you're wearing their t-shirt. So I kind of want to talk a little bit more about the high-level overview of what Poseidon Systems can do today in the wind sector. And then if you also want to talk about other sectors too, I'd be really interested about that as well. But really delving deep into the details of what that actually looks like.
Yeah, so I mean, I had a high level within wind. We are providing a condition monitoring system. So that is primarily based off of our wear debris sensor. It's the DM4500, DM4600. That's a majority of our installations. Today we have, again, in the past 3 years, which has been the main focus of our commercial work in wind, we have been retrofitted over 5,500 wind turbines in the past 3 years. We're looking to probably more than double that this year, so we should hit around 12,000 at some point this year based off of installation timing and that sort of thing. And all that really has come down to a lot of uniqueness. One is our wear debris sensor it's the best in the market. It's the highest sensitivity. So we see wear debris particles that are much smaller than some of the competition. We also see a wider range. So even though we see the smaller particles, we also see the big ones, which are really good indication that something's going wrong. And then we have a very unique way of looking at that data, which kind of has given us the edge. And that's kind of the base of what we offer in wind. From that, because we've created such a flexible system in terms of data connectivity, we can send that data directly over the SCADA system. That's probably 85% of our installations. It plugs right into the site network and goes right into the customer PI system. And because none of the data that we're collecting needs advanced analytics or that sort of thing, it's very easy for our customers to monitor it themselves. We do have, again, flexible capabilities in terms of being able to get it through cellular. We've just recently integrated and started testing LoRa, which is like a long-range wireless. We can have a central gateway kind of in the middle, and line of sight, we've tested it up to 6 miles. So you can kind of capture maybe 10, 20 turbines worth of data and come through maybe either one cellular connection or one SCADA network connection back down tower. And again, these integrate back into the controllers on some turbines as well. So because of that flexibility, our customers have asked us to do some unique integrations. So we've expanded into main bearing monitoring, generator bearing monitoring using some wireless Bluetooth vibration nodes. So it's a real quick installation. There's no wires. They last up to 3 years. And we're getting vibration and temperatures on those components to monitor, as well as integrating some third-party connected breathers. We have our own oil condition sensor, which allows you to replace the periodic oil sampling and use those oil samples just as a way of determining what may or may not be getting wrong. So we have a very small scope when we started, and because of the way we designed the system, trying to be more of a solutions provider to fix the customer's needs, we've been able to add things here or there to provide a little bit more of a complete solution to the wind customers.
That's fantastic. And I guess for additional context, a lot of our listeners too are people who are going through college now, either technician school or they want to be more on the engineering side like you were going through, Stephen, as you went through Clipper and other companies. What is the traditional way? Like what did you guys replace with this new system that's obviously streamlined, easy to read data, easy to capture data? If I were working in wind prior to Poseidon and prior to this technology being rolled out, what would I have to do to be able to collect these samples and collect all this data to allow my turbines to run more effectively?
Yeah, it matters on what we're integrating. So if we look at the wear debris sensor, it's really trying to fill, mostly in some cases, it's filling a hole where maybe vibration doesn't do as good of a job. And so, for example, vibration is getting better at, but not great at early detection of planetary bearing faults, which is really about 50% of all gearbox failures. And so we're providing the best solution, the early detection, the highest catch rate solution for that of what makes up a large percentage of the gearbox failures. There's also some new failure modes that pop up all the time, such as some slipping and clocking out of races. And so what we found is we can look at the time series of our data, the way that we look at it, and get earlier detection there so you can do a quick repair, as opposed for that to cause some secondary damage. And if you look at the new technologies, they didn't have these out before, so it's not like we're replacing anything, but journal bearings are starting to come out on the new turbines. And really the only way vibration can't do that today, especially since they're going on the planetary stage, is to use wear debris as that monitor. And so since we have that wider range and smaller detection size, we're able to more effectively catch those, whereas that was just a giant hole in the system. We do have some customers that have, and kind of the conclusion I made at Clipper, as a low-cost retrofit on some of the older turbines, just using the wear debris sensor to monitor the gearbox provides a significantly high amount of ROI, which we'll talk a little bit about later. And so in some cases, we are just straight replacing the vibration system, or in place of retrofitting a vibration system on a turbine that does not have any condition monitoring. It's just the wear debris sensor to monitor that gearbox, and then using the wireless vibration nodes on the generators and main bearings.
That's really interesting. So are a lot of the older towers that were put up, do they come with a built-in vibration system then?
There was a certain time frame where it transitioned, where the OEM said, well, we need some sort of condition monitoring. Vibration is a very proven, approach. It's been around for a long time. There's a lot of different suppliers for that, and they've done a good job implementing that. So they went with vibration. It's much lower to include with the turbine that's being built as opposed to retrofitting. So they built it into their systems, and they've gotten a lot of good value from that. Our position is, if you can afford both, absolutely put in both. So there's a period of time where it transitioned from not really having any. At Clipper, we provided both vibration and wear debris on the turbines, which was unique at that time, around 2005 to 2008 time period when those were sold. And then during that transition, everybody else started to also do that. So they started adding the 2010 to 2015. It slowly meandered that all the new turbines came with those. So there's an older set of turbines, tens of thousands of those turbines, and worldwide hundreds of thousands of turbines that don't have any sort of condition monitoring. That's slowly changing as they're being retrofitted. We think we provide a pretty low cost solution for that where there is nothing.
That is really interesting to just see the evolution of the technologies, from the OEMs to the aftermarket, what you guys are able to do with these different sensors that you can mount and the data that you can collect. I'm really excited to kind of see where the industry goes over the next decade, 2 decades, and we'll talk about that in a minute. I definitely want to hear from you, and this might be kind of a dumb question, so I apologize in advance, but is all of this that you're talking about online oil quality monitoring? Then does what you do fall under that specific umbrella, or is that also vibration analysis and all these other testing protocols that you can implement in these towers? And obviously I've done a horrible job defining it, so I'd love to just hear from you what exactly that is.
Yeah, so I mean, absolutely, the majority of what we do is more this inline oil condition monitoring with using the fluid, using the oil as the basis. So the wear debris is trying to solve one problem, which is is there a failure in that gearbox, and detecting that failure early, and then also using that sensor, which we do in a unique way. None of our competitors do this, as a life gauge. How is the progress of that fault coming? Is it getting towards the end of life where it might become a catastrophic failure? If so, what could you do to reduce the amount of damage being done on those components to make them last longer, right? So doing some life extension. We're doing all of that through the wear debris sensor in terms of the gearbox. And so that fits under the same thing that you'd be trying to get from oil samples, but you don't really get from oil samples. The other sensor, the oil quality sensor that we have, it's an impedance type sensor that's monitoring different frequencies, and it's trending in general overall oil health, so that you could use that instead of your oil samples that you get every couple 6 months, or maybe twice a year whenever you go up tower to get those. So that, again, that's still under that oil condition monitoring type of thing, and that is the basis of our technology, what we do. Because we've been so successful in that, the next question our customers asked was, well, can you add generator monitoring, main bearing monitoring, or some of these other technologies? The answer was yes, we could. We had a very adaptable solution. So we have also added some basic vibration capabilities so that we can do the full drivetrain, or we can do a pump that's sitting over to the side in a low-cost fashion, as opposed to a higher-cost vibration system.
That's super interesting, and I appreciate that overview. I've learned something new already, a lot of stuff new, actually. The next question that was prompted out of that is, so if you already have a customer who has vibration systems installed, how do you kind of market or complement your system with somebody who already has those vibration monitoring systems?
Yeah, and we probably have it's roughly, or was 50-50 split between turbines that have vibration systems, turbines that don't. We have some customers that just install our sensor as a low-cost way of getting that value. When you do have vibration installed, there's some blind spots with vibration where it doesn't do as great of a job, or it can't do today. One of those we already talked about was planet bearing fault detection, which is a good chunk of those. And so we have some customers that they buy a turbine, a year later they install our sensor on top of the vibration system that's already there, so they can get full coverage and early detection of all fault modes through the vibration and through our sensor. And we've shown with those customers that there have been planetary faults the vibration system didn't alert on, and our sensor was able to do that. So you have obviously value there, preventing catastrophic failures, split casings, that sort of thing. Again, those new failure modes we talked about, the slipping clocking out of races, that's a value, obviously, because you could end up having to do a full up tower high-speed bearing replacement, or in this case, it could be a planetary one as well, which would be even more costly. Being able to go in and either whatever the solution is at the time, this kind of changed pinning, Loctite, whatever it is, the solution for that particular one, and making sure that that solution works. We've seen some of those solutions come undone and then start having that same problem again. So before it starts actually spinning and causing a lot of damage, being able to find that quick solution up tower very quickly, as opposed to doing an up tower retrofit or a gearbox replacement because of that. And again, a lot of these new turbines are coming out. Their turbines are already being installed. They have journal bearings on the planetary stage of the gearboxes, and really the only cost-effective solution to do that on wind turbines, especially because it's on a planetary stage, which is always in motion and moving, is the wear debris. It's very cost-effective. And all three of those sort of things are capabilities of detection that the vibration either doesn't do well or doesn't do. Then on top of that, our customers have now been using the sensor in conjunction with us to, again, look at from a life gauge, life extension solution. So how do you use the amount of debris being generated by a fault to determine the severity, the progress, how fast is it failing, and then how can you slow that fault down so that you can extend its life. So we're measuring the damage being done to that component. How can we reduce that damage that's being done to a level that's safe to operate the turbine? So we have a lot of different success stories in that area.
Can you cover how you guys actually are able to slow down the damage that's being done that you're able to track?
Yeah, probably the more common one for owner-operators, because there's a lot less tools available, especially on some of the older turbines. There's just a lot less things you can change. One of them would just be a derate. Using the sensor, instead of kind of guessing that if we derated the turbine by 50% it'd last 6 weeks, we actually used the sensor, derated a little bit, what we think makes sense, then look at the output. What's the debris being generated, and is that within safe operating levels? And then we kind of work that back and forth until it's at what's the highest power production we can make during that time, so that we can obviously have a higher return on investment to operate that turbine, but still do it in a safe manner. And we do that basically, the risk of a catastrophic failure on pretty severe bearing failures actually goes down to roughly zero, because we're able to very successfully put that turbine in a state where it's not going to cause those faults. When you look at these more advanced turbines, and some of the stuff we would do with an OEM, you can do more advanced control changes. You can find kind of the exact conditions through the SCADA data that's causing these higher load events, which are then causing higher damage, which is what we're measuring as the damage being done, and then eliminate those. So there are maybe conditional derates, or there are other controller settings that are available that the OEM can change, or are available on the newer turbines, where instead of a total flat derate, you can do some condition-based derating based off of maybe turbulence or wind shear or other things like that.
So really the alternative to the derating and utilizing your technology, and correct me if I'm wrong, is catastrophic failure, or you take that turbine offline, trying to figure out how to replace those main components, such as like a planetary swap out, basically. Is that correct?
That's correct. Or you just do a one big derate and you hope it's enough, but you really don't know, right? It's uncertain.
Wow. That is really cool, and we're going to get into the economics, and I'm really excited to talk about that. We had a user submitted question. I was talking to some customers who had actually known about you, and one of the questions that was submitted was, how important is the quality and the maintenance of the ancillary components to the gearbox for optimal performance? And one of the examples was, for instance, the quality of your gearbox hose assemblies. How does that really tie into the long life, high performance of, for instance, the gearbox?
Mm-hmm. Yeah, one of the unique things we've done as well is there are some things like, not everybody loves desiccant breathers, but some people do. And so there's kind of an argument, next week we'll be at the DRC and they'll argue about whether a desiccant breather has value or not. But some customers absolutely love them. One of the unique things that we did on the integration was a connected breather, Bluetooth, and it gives you the life of the breather. And I presented at CanWIA last week one of those examples where we had two turbines side by side. And the desiccant breather on one of those turbines, again, same site, same location, side by side, climbed up one, installed it, climbed up the other one right afterwards. One of them ran through the breather in 3 months. It sucked down, the life of the breather, 3 months, 3 months, 3 months, 3 months. So basically you're running 3 months if you're doing it every 6 months, where that desiccant breather is unable to provide any value, pulling humidity out from the outside air or from inside the gearbox out. The turbine next to it was at 50% breather life after 18 months. And so, if you have basically just every 6 month replacement, one, you're wasting money on one turbine. And the other one, if you really think there's a lot of value coming from the desiccant breather, which, you want to keep humidity out of the gearbox, that's pretty important. You would be running 3 months, half of that cycle, where the desiccant breather is not doing anything. So when you talk about how these ancillary systems, when you start to connect, and that's kind of why the IoT plays into here, these other devices we've been asked to connect into, you start to see where the performance of those ancillary components actually become important. And if you can connect them and monitor them, those are great. Another one is the filter. So obviously there is typically a pressure check valve, right, to go to bypass as a way to protect the fluid still flowing. In our sensor, we've been working on some calculations to look at the particles passing through and detect the flow rate and then track and trend that. So we can say, hey, you're getting close to a potential bypass, so you could go change that filter. And again, if the filter goes into bypass, now you have debris not being filtered out, which debris obviously causes secondary damage on the components in the system. So adding a little bit more monitoring into those ancillary components, the hoses and everything else, whether it be higher quality or monitoring of those, definitely play into the gearbox performance and capability of that gearbox.
That is really interesting. And this is all your tech that you're able to monitor these different ancillary components too.
That's right, correct. Yep, either our sensors or third-party sensors we've integrated.
And then you guys are able to collect that data and then present it to the customer and say, hey, here's where the best bang for your buck from performance, recouping, your return on investment, reliability, the life cycle of that product, and so forth. You could just present it, they could see the data and make the best decision moving forward.
That's right. And in a unique fashion, that can be presented through our software, or it can be done through the customer software. Because again, none of the sensors that we are presenting can't be pulled directly back into the SCADA system or the PI historian, if that's what they're using, so that they could also have monitoring and self-monitoring of these components and these sensors. So it's much easier way of integrating some of that monitoring capability.
And is that all done in real time? Could you, if you wanted, or is that over time you take a snapshot and you're able to chart and do all the advanced mathematics and everything behind it that I certainly don't understand?
Yeah, we typically have a 10-minute data sampling. So basically, the wear debris data, oil condition monitoring, all the other ones, we're taking snapshots roughly every 10 minutes. Some of the sensors we could do more, but we're finding for wind turbine operation, one, if you're only able to compare it to SCADA data, there doesn't provide a lot more value in between. And then two, not a lot changes in terms of a cumulative amount during that time frame. So getting a cumulative change in wear debris in a 1 second period is almost useless, whereas the 10 minutes seems to be pretty good and analogous to what our customers are already used to seeing. In other industries, we definitely do different data rates, but there are unique situations with vibration where you have an FFT where that would break that rule, right? Where you're getting high frequency data that you have to have the ability to analyze on top of that. But in general, the rest of the sensors are lower fidelity 10-minute type data.
That's awesome. I appreciate that insight too. I actually grabbed the quote from your LinkedIn. We've talked a lot about this already thus far, but I just want to get your direct feedback on it because I thought it was really interesting. You had posted a study to your LinkedIn, and here was part of the conclusion. The utility of offline oil analysis for identifying gearbox failures is compared to that of online wear debris monitoring. Ultimately, the evidence shows that offline oil analysis results provide little to no correlation with gearbox health, while online wear debris monitoring provided direct correlation to gearbox health. Can you kind of break that study down for us, or at least the conclusions of that study, and kind of wrap it all up for me and then also the customers that are listening to this?
Yeah, so that is a white paper study we did with EDF Renewables. So shout out to them for providing obviously the data, since they're the ones that own the wind turbines and we don't. But we sat down, we did that work with them. We did a study of approximately 140 gearboxes. And from that study, we turned it into white paper. It's free to download. You can go to our website and grab that if you want to have the actual data and statistics to make sure that you understand what it is that's being, what I'm about to tell you. But basically, across the roughly 140 gearboxes, we looked at a 5-year window. We looked at the first 3 years, and we used all the samples that were available, and we looked at the ISO cleanliness particle counts, and then we also looked at the overall concentration levels that came from the lab samples. And then because we had that 5-year window, we had 2 years tacked on the end. Obviously, we had a long enough time period to say, okay, well, did a failure present itself in the data that led to a failure later? And then how did that compare to what we would consider healthy gearboxes that did not have a known fault during that 5-year period? So giving us that 2-year buffer at the end solidified, obviously, whether or not there was an actual fault within that turbine. What we found was the lab sample levels for alerting on ISO cleanliness and then just overall concentration. You had basically a lot of mostly misses. So if there was a fault in that study, we actually found one of the turbines was above the warning level, never above the alarm level. We had lots of healthy gearboxes that were above the alarm level and above the warning level. And then we had lots of failed gearboxes where we have borescopes of showing large amounts of damage, as well as our data in parallel with that on some of those installations, where we were able to show, hey, look, there's wear debris being generated. Our sensor sees it. We're accumulating it, but the lab samples coming back saying the ISO cleanliness is fine, the overall concentration is fine. And really this comes down to the specifics of this application, wind turbine gearboxes. So if you look at the process of taking an oil sample, you have to shut the turbine down. So now there's no longer fluid being pumped through the lubrication system, so things start to settle immediately, especially the larger particles. If you look at the chances of those larger particles, 100 micron or above, showing itself in a lab sample and that particle actually getting in, it's already a low chance based off of the volume, that 4 to 6 ounces you're pulling off in your sample. It's already a low volume, let alone it settling out. And two, the question is when did the technician take that? Because typically you're starting at the base of the tower. You're not starting with taking your oil sample. There's a time period involved there. So by the time you get up there, that sample is not really representative of the 4 to 6 ounces that you would get during the operation of the turbine. Secondly, even if it was statistically, whereas we'll see tens and hundreds of thousands of 100 micron particles, you have a very, very low likelihood of even seeing a 100 micron particle in that sample. And so in that white paper, it delves out, here's the statistics, why this is true. Here's the results from that study on a large gearbox kind of study across multiple turbines across a long period of time with enough time frame at the end to make sure we knew confidently that they were failed or not. And so we were able to then compare that back to the online across some of those turbines that we were installed where there were faults, and we were able to see, we clearly saw it in our data. And every time we lined up the oil analysis where it came back fine, we were seeing huge pitting and spalling on a planet bearing, for example.
Wow. That is crazy. So this actually is a perfect segue into the next question then. Obviously, if you have your sensors and systems set up within a wind turbine, you can actually catch these faults and catch the debris that's going through the system. Another question that was asked was, can we go over the economics of Poseidon Systems, your sensors and your different systems that you can actually implement within these towers? Can you kind of give us a breakdown of what it looks like to install, what the long-term cost savings look like? Because ultimately that's the goal, right? Keep costs low, keep the renewable energy sector moving forward and growing, and then obviously producing power and saving the owner-operators money. So can we kind of go over that, if you don't mind, Stephen?
Yeah, there's a couple unique points, I guess, with our system when it comes down to the economic benefit. Obviously, you want to know the cost, right? How much it's going to cost me to do this, and then what you're going to save. When you talk about the installation, our installation, we have a video of it online. We're pretty open about what that looks like. When you look at a gearbox that does not have a CC Jensen filter, we have basically two versions of our sensor. One plugs directly into the CC Jensen, so there's no extra hoses. There's just a longer bolt kit. You unbolt the CC Jensen, you put our sensor in between, bolt it back together, and then you have a sensor cable that runs to the data logger, which gets plugged in. So when you think about that process, it's a 30, 45-minute process when you're up tower. So taking that off, you could very easily add this kit to your 6-month maintenance, have a technician bring it up with them, do that installation. It doesn't add hardly any time to the work that they're doing already. The other installation when you don't have a CC Jensen is we just add a hose kit. So now you're adding a T-fitting to a sampling port. You're attaching the sensor somewhere with 2 hoses. So every technician's trained on obviously how to do hoses and Loctite and that sort of thing. And then connecting it back into a return port on the gearbox. And again, these are always have work instructions And again, it's that one may be a little bit longer, closer to 45 minutes to an hour in some cases, easily added on to the to work that's already been done on the tower. So when you talk about cost of installation, it's fairly low compared to other systems. The vibration system could be a half day to a day, depending on that system, to get everything kind of glued and put in and everything else like that. When we talk about cost of the system, a alternative systems like a vibration system, again, you're looking at typically 5 figures for the hardware and installation, whereas we're looking at a low couple $1,000s for our sensor if we're just looking at gearbox installation. So your hardware cost is significantly less. And then you look at the monitoring cost. We do have probably more than half of our installations are self-monitored by customers. So we do like to give 6 months of monitoring to our customers to make sure they're getting value out of the sensors. They can learn how we monitor the sensors, and then they can make a decision to self-monitor or not. Again, we kind of have a mixed direction of what they want to go with. Typically, vibration companies are charging $75 per month per turbine to monitor that system. We're going to be anywhere from $15 to $20 per month per turbine. So that extended cost is not there. If you were to do it internally, obviously, then you have your internal cost to do that monitoring, and our cost is not there. So when we look at the overall cost of ownership of this system, you're not fixing vibration nodes, you're not fixing cables, the cables aren't there. You have one sensor, cables, some hoses, and a data logger. So there's less things to break, so your overall cost is lower. And if you want to, you can self-monitor. So that reduces that overall cost. When you look at the value side of things, what do you get back from it? A lot of it, obviously, if we're being installed in place of vibration, everyone's pretty aware of the value of what a vibration system would do. You get detection of faults that you wouldn't know otherwise. You get those detections earlier so that you can plan better. You can prevent catastrophic gearbox damage. So that would all, those values would all kind of correlate back to what we're doing. If we're doing it on top of a vibration system that's already there, we're talking about those failure modes that we talked about earlier that vibration isn't great at. We were able to detect much earlier, as well as the ability to do things like the smart derating, the life gauge, the extension of the operational life. And in some cases, we've added 2.5 years of operation, whereas that gearbox may have been replaced at that time. It was in full operation for like a little over 2.5 years. And then we added another 6 weeks of derating operation before they got the crane in. So for that cost savings and avoidance, it's quite high. So you're looking at things like a $250,000 or $300,000 gearbox replacement, moving that down to an up tower replacement, closer to a $60K, or even if you still have to replace the gearbox, you get your $60,000, $90K core that you don't have to replace because you can reuse the gearbox housing. Or in another case, some of the value is where you get installed, like I talked about the one customer, a year after the turbines are installed, and they're using us for end warranty inspections. If there is no debris in the system, then there's nothing to see on a borescope. So they only borescope the turbines that have enough debris shed and detected through our system. So they're reducing their borescopes, and then they're spending more time making sure they get really good pictures for warranty claims. So it's a nice approach for customers going through that end of warranty transition. You get a $300,000 gearbox replacement, you might have a year later turning into $0 under the warranty claim.
That is awesome. So not only is like the upfront investment, just looking at cost of goods lower, the ultimate value long-term also pans out. And correct. As somebody who wants to be a consultative salesman in the industry, I mean, that's a no-brainer to me. Right. I could be biased, but honestly, that makes a ton of sense. And I love that you were able to break down the value adds, not just from the cost of goods standpoint, but also what that means for uptime, production, swapping out gearboxes. Crane costs are just crazy expensive when you have to think about how high and how heavy those gearboxes are. So I appreciate you breaking that down. Obviously, we're talking about value and the value add of Poseidon Systems. I want to actually hear from you about some big wins before we head on to the rapid fire round. So do you have any big time wins with a particular customer? You don't have to say their name, obviously, that you could maybe share with us just to kind of reiterate what it is that you guys are doing over there that's so innovative.
Yeah, so we talked about individually what the things are that we're doing, so how does that translate into big wins? So if you kind of look at the statistics of some of our customers, nothing's perfect, right? No system's perfect. There's reasons why things fail and aren't seen, but we have a significantly higher catch rate. So we have some customers who would have several catastrophic gearboxes per year on a fleet of a couple thousand, have gotten to a 100% catch rate with no catastrophic failures on our installed fleet. And so that's a big one right there. It's hard to go say, oh, we blew up another gearbox completely and turbine shut down, oil's everywhere, we got to buy a brand new one now, and instead of saying, okay, well, we prevented the gearbox from being, catastrophic falling down, we either derated it or turned it off or whatever it may be to save that from happening. And then now you have time to figure that out. Or if you catch it even earlier, start planning for that and saying, okay, we're going to do these two gearboxes at the same time, save mod costs and do that those replacements together. So again, success rate 100% in some instances of no catastrophic failures with that catch rate. The other case we talk about warranty claims. Sometimes we're getting one or two. We had one customer early on get 6 that they would not have gotten otherwise. It didn't spend a little extra time on those bore scopes on a particular turbines, and they were able to add quite a few to that site to get replaced. Which that was obviously quite a huge savings and for a very low investment. When we see customers do that on the warranty side, they typically pay for the installation within the end of warranty, and then so anything after that, that's pure savings, right? You already had the sensors, you paid for them. In this case, you may be self-monitoring, so anything after that is on top of the savings you already have.
Those are some huge wins. So you were able to dial in 6 gearboxes for a particular customer that were
Correct.
Sent in for warranty claims. And is that also, so that's pulling them, getting a new one, and then installation?
Whatever that particular warranty allowed for, yeah, and typically that would be the case.
You've got to be a superstar for that customer. Oh, I'm sure. That's awesome.
That's those type of wins. That's how you go from a couple hundred to 5,500 to this year breaking 12,000. Right,
12,000, and that's across all different owner operators. Is this primarily turbines that have come off of OEM warranty then that you're working with?
Primarily, the 5,500 is mostly off warranty turbines. The 12,000 or so that we're going to break, a good majority of those will be under warranty, going through that transition period, so they're preparing to self-operate. And a lot of other approaches. So that's the kind of the mix of what we're looking at to double our installation fleet this year.
That's excellent. So there's a large variety of customers that are, could potentially be listening today that could really leverage this service, obviously based on what the agreements they have in place. So I just definitely want to reiterate that you guys can service a lot of different customers in the marketplace, and I see how important this truly is with such a low cost investment. And then obviously your engineering background, your team's background, your expertise, this is a no-brainer to me. Obviously, and I think a lot of people would benefit from this. So Stephen, we're moving on to the rapid fire round. Are you ready?
I'm ready.
All right. So first question, and this is for a lot of people, either young to old people, or maybe making the switch into wind, or they're currently studying different wind energy technologies. This is a question that I reached out to people who are non-wind and told them a little bit about your background, and they wanted to hear an answer to this as they kind of accelerate their career. So you've obviously worked successfully with many different startups and different companies. What do you feel has allowed you to thrive in early stage growth for a wide variety of different companies?
I would say that the first point is true in all companies, whether it's early stage growth or not, but it's probably even more important in early stage growth, is just be willing to do what is needed at the time. So the condition monitoring system, I didn't know anything about that before I started it. Obviously, I'm in condition monitoring now. So my career path never would have got here if I didn't do the one thing nobody else in the company wanted to do. Everybody wanted to work on the new turbine or whatever it was. But it really served me well just to be like, okay, yeah, I'll do it. Absolutely. And I've done that several times, and that's moved me from engineering to a little bit more customer facing to product design and other things, because it was just things that people didn't really want to do, but were important. And I don't think people noticed that. So if you're willing to do what's necessary without getting too big of a head, and just getting that work done, you fill in a lot of gaps, especially at an early stage company where there are a lot of gaps. We don't have 150 design engineering team. We could utilize 150. But even if you're more on the customer facing side, being willing to do some of the engineering stuff, if you're on the engineering side, being willing to support the customer facing stuff, whatever it may be, being willing to do those projects to fill in those gaps. And so it's more true in the early stage side of things It's even true in the large companies as you look at a career path. But I wouldn't be here today if I didn't take the mentality of, I'll absolutely do that thing that nobody else wants to do, get it done, and do a really good job doing it. And I think that's important.
I think that's a phenomenal answer, and it's a perfect dovetail into the next one. You mentioned you have 4 kids, one of which turned 16 today. How in the heck do you balance doing what you do, being on the road as often as you are, working at a company that's obviously growing, doubling in the amount of fleet that you're servicing in wind? How do you balance being a husband, a father, having stuff to do at home, and then also pouring your heart and soul into your career?
Yeah, so I don't have a lot of extra stuff that I do outside of family work, church-related things, and then obviously trying to stay healthy and making sure I eat right and work out. So I have a very structured day. There's time in the morning. There's the let's say the first section of work, which is the 7 to 5, but I stop right at 5 to have dinner with family, help with baths, put them to bed, all that kind of stuff that you'd expect to do. And then reserving some time before bed, being able to finish up some things and having that strict structure when I'm home to make sure that I'm doing all of those things every day and not missing any of that. So it's being very purposeful with that. And you just like anything, if you have a to-do list, making sure you do all those things and not leaving one of them off, whatever that one thing is. And when I am traveling for work, right, so there's a lot of travel involved with doing what we do, making sure that there's time reserved either in the morning or the afternoons or in between things to call back and have conversations, FaceTime, and all the other cool things we can do now with technology when we're traveling. So it doesn't hurt that my wife's amazing and that she's able to take care of 4 kids ranging 16 to 1.5 years old. But that obviously is a benefit, all the work that she does. But being very purposeful and being on the same page, right, with my wife and everything else. And so it's making sure you don't forget all the things that are important and not adding too much stuff to your time. Even people who don't have 4 kids are always busy. Why are we always busy? Because we just have too much stuff. So when you add in the things that you'd say is more important or a commitment, making sure they are important and a commitment, and really honing in that time that you have.
I love it. So basically, shout out to Mrs. Steen then, right? Absolutely. That's the answer.
Right.
She sounds like a wonderful lady. She's got her hands full, but obviously you're a wonderful human being too. And I like how you're talking about being very intentional and purposeful with the things that you do. I think a lot of us professionals, or even people who stay at home and take care of kids, have to really hone in on what's important here, saying no to the things that maybe aren't so important and not constantly adding to that to-do list. So I really do appreciate that answer, Stephen. That's something that I think a lot of us can carry on throughout our careers, whether we're early on or late stage career. So I appreciate that. Speaking of late stage and growth and acceleration, how do you anticipate this wind market changes over the next 5, 10, 15, even 20 years? I mean, it's been crazy from even just like 2008, 2009, before then with Zon turbines and all these different technologies, the lattice towers. If we were to look ahead at 2030, 2040, what do you think changes?
Yeah, we're certainly not done with consolidation. Consolidation of the owner-operator side. It's just, in general, it's more efficient to operate a larger fleet, and maybe not too large of a fleet, but certainly more than 1 or 2 sites. So we're going to see anyone who stays a little bit longer, their fleet's going to get relatively big. If you look at the turbines that are going in now, they're 3 to 4 megawatts even on the onshore side. They're huge. They're big. So I think we just kind of the 2.5s went by really fast. We went from the 1s, the 2s, and now we're looking at 3s already super quickly from a scale perspective. So they're getting big fast. I don't know if that means they'll skip over the 3s and the 4s and go to 5s and 6s really, really fast too, but we're a little bit less land constrained here in the US, so probably not too quick on that side. We're just starting offshore, and that'll probably start to bloom as we start to see some of the good locations go away on the new installations. So obviously, what used to be 5 or 6 people getting together talking about offshore wind for the US, they're having a little bit larger locations. Some of that consolidation's brought some of the European offshore operators to have ownership here and operations, and there's clearly more of a push for direct drive. I think you see that starting the offshore. When we start to get on the onshore and have the larger turbine sizes, now we're talking about technologies that maybe the current technicians and engineers don't have experience with. It'll be a little bit newer. So you're going to see that transition probably over the next 5 to 10 years as they get way bigger, they move locations, and even the ones that are here are going to be different technologies like direct drive.
Yeah, direct drive, I still don't 100% understand it. And I guess you're an engineer. I hope you know this answer. Do you know how the direct drive technology works in like a 30-second wrap up? It's something that I've never worked with personally.
Yeah, there's a couple different ones, but the idea behind it is instead of having a gearbox change the slower rotation, higher torque into a faster speed, lower torque situation, which means you can have a smaller generator, so it's higher voltage, lower current. Now you have this. The best way you can get that ratio is you make the generator bigger than the rotor shaft as much as you can, and so there's some that like the Enercons and other ones, they just have these huge giant magnet direct drives. In other cases, they're a little bit smaller, and so there's just the really high torque, low speed generators, permanent magnets that there is no using the mechanical advantage of a gearbox to get you there. So benefit, you don't have a gearbox, which obviously causes quite a bit of problems, but for us, eliminates some business, I would say, because there is no gearbox. But you have a little bit more upfront cost, right? So a gearbox, smaller generator is typically lower cost than a very, very large direct drive. But simplicity in the mechanical electrical design is always helpful as you get to those larger wind turbines where you can make a little bit more of that investment.
Interesting. Good feedback. I actually want to move on to sports. So we talked a little bit about this offline. I thought it was a great story, so I really want you to share this. You grew up a Lions fan, and you're from Ohio, right? Born in Ohio?
Yeah, so I grew up at Toledo. It's right on the border of Michigan, Ohio. So like you can walk in and find, I would say 50% Browns fans, but you're within an hour and a half of Detroit. You're 3 hours from the Colts. You're 4 hours, maybe 3 hours from the Bengals. You're 4 hours from Chicago. You're Pittsburgh's 5 hours. So if you kind of look, like you can find all of those teams plus whoever likes the national teams, right? The ones everybody likes, the Dallas and the Niners from that era. Holdovers, there's just a huge wide amount of people who liked it. I was closer for whatever reason. The Lions were the team, unfortunately. My dad liked the Steelers. His team won, mine didn't all the time, so there was that. But for whatever reason, it was close enough. Barry Sanders was the running back. Who doesn't like Barry Sanders? So it was kind of like you like Barry Sanders, you like the Lions, perfect. You were really close. So that made a lot of sense. But in general, I really don't care about the NFL anymore. And the reason was that we moved out with Clipper, we moved out to California. Lions weren't on the TV very often, right? NFL has their different networks. On the West Coast, nobody cares about Detroit Lions. That's just the way it was. But Ohio State, which I did love, they were on all the time, right? Ohio State national broadcast basically every game. So when the Lions basically went 0-16, I kind of didn't care anymore. It was hard to care about them, and so I kind of went full bore into Ohio State. And then secondly, with that time management, I couldn't take Saturday to watch all the games and Sunday to watch all the games, and Monday night with the kids, I kind of had to nail that down to just a couple. And so I kind of just said, okay, I like college football. I'm going to stick with Ohio State. They typically win, have a good time, as opposed to losing all the time like the Lions did. And kind of fun XFL, following Ohio State players in the NFL, or now in XFL with Cardell Jones at the DC. Kind of fun to see them go from college to NFL. So I might catch an Ohio State player playing at kind of different teams here or there.
So who's your favorite Ohio State player of all time, if you can actually dial it in?
All time would be tough. That would be a tough one, but some of the really good ones turned out to be maybe not the greatest people, and so I typically would be like, all right, you may be a great football player, but I really don't like you. So there's more recent players that were like that, amazing NFL football players, but I don't love. In general, I would definitely say, at least right now, Michael Thomas was obviously should have been a first-round pick. All of us saw it. Went in the second round, now killing it in the NFL. He's very likable, good guy. That's probably one that stands out.
I love that pick. Love Drew Brees too. I thought they were going to win it all this year. They looked very dangerous. Michael Thomas, though, setting that most receptions in a season NFL record this year.
He did the season, and then he's still setting the record each year, how many receptions he gets in his first X number of seasons. So every time he has a new season, he sets the next record of number of receptions in the first 4 years, 5 years, probably continue on. Even
That's a
without
great pick.
a handful of games, right? Even
Yes. Who was it? Jacoby Brissett was the quarterback for them, or who?
Bridgewater.
Oh, that's right. It was Bridgewater when he had that nasty leg injury too, which was brutal to watch. No, that's great. Ohio State, good team. I grew up a Stanford fan, so sometimes they would play, and it was always tough to just get walloped by Ohio State, but I can still respect it. I like the choices, and obviously Michael Thomas is an excellent player, excellent human being, and it's tough to distinguish between the two. So last question. I want to wrap it up here. It's been an awesome conversation, Stephen. How can people find you? Website, LinkedIn, obviously. We can put this in the show notes. We can put it on a blog as well. Are you on Twitter? Where is a great place for people to get in touch with you?
Yeah, LinkedIn's the best. Again, kind of time management, not a lot of time for social media. I actually shut down Facebook and a lot of the other stuff. I think a lot of other people have done that as well.
You're not missing out, by the way.
Yeah, I know. So LinkedIn, easily the best way. And then Poseidon email address, it's stephen.steen@poseidonsys.com. Pretty easy to find. Will be in the link. But those are the two best ways to get a hold of me.
Awesome. Well, Stephen, I appreciate the time today. I've got a ton of notes here, too. I really want to wrap this up and kind of encapsulate what we talked about. If there's anybody who does want to get in touch with Stephen, we'll have all this information in the show notes. Really appreciate the time. You've been super generous with it. It's basically an hour that we've been chatting. And I wish you good luck in your professional endeavors. Keep up the good work. Happy birthday to, was that your daughter that you said it was turning 16 today?
Yes.
So obviously the funny joke, I'll make sure I stay off the road today. But in general, good luck with everything. And we'll definitely be in touch, Stephen.
All right. Well, thank you.
Appreciate it.